Find the particular solution to the differential equation below under the given initial conditions. So the initial conditions are that if you plug 4 in for x into the first derivative, you get 2. And if you plug 0 in for x into the function, you get -3. So these are the initial conditions. Initial conditions. And you may see something like this. So the equation that we're trying to solve is this guy right here. And you may see this written a slightly different way. You may see d2y over dx squared equals. So that just means the second derivative is equal to x to the -3 over 2. All right, so to solve this, well, we're going to have to find the antiderivative twice, or the indefinite integral twice. We're going to go from the second derivative up to the first derivative, and then from the first derivative up to the function that we're looking for. So if the second derivative is equal to x to the -3 over 2, then the first derivative should be the integral of x to the -3 over 2. Now, we're looking for the particular solution. So remember, when you're finding an antiderivative or you're evaluating an indefinite integral, there are always infinitely many solutions. And that's because of the plus c, or the constant of integration. So we're looking for the one specific antiderivative that meets this first initial condition. And then when we take the antiderivative again, we're going to look for the one specific solution that meets the second initial condition. Okay, so if we apply the power rule for integration, we'll get x to the -1/2 power divided by -1/2 plus c, or we could simplify this to, let's say, a -2 over x to the 1/2 power. All right, so that's the form that our derivative will take, or the form that f prime of x will take. But now we're going to use the initial condition that since f prime of 4 is equal to 2, so if we plug in a 4 for x and a 2 for f prime of x, that tells us that 2 should be equal to -2 over 4 to the 1/2 power plus c. And this is going to allow us to solve for the particular constant of integration, the particular value of the constant of integration. Or 2 is equal to, well, it's -2 over 2, which is -1 plus c, or c is equal to 3. So there's our first constant of integration. So that tells us that f prime of x is equal to -2 over x to the 1/2 power plus 3. Okay, so now the function f of x, well, that's going to be the antiderivative of f prime of x, or the indefinite integral of -2 over x to the 1/2. I'll write that as a -2x to the -1/2. I'll write that as a x to a power, because we're going to be using the power rule, plus 3. Okay, so we're taking an antiderivative of the antiderivative of the given f double prime of x. All right, so when we take the antiderivative of -2x to the -1/2, so there's a -2x, we'll add 1 to the power, so that's 1/2, and divide by 1/2. And the antiderivative of 3 should be 3x, plus another constant of integration. Let's call this C2. We'll call this C1 and C2. Okay, so our function is going to take the form of negative 4x to the 1/2 plus 3x plus c. That's c2. I'll just write the c. And now we have, now this is infinitely many functions here. We want the particular function under the second initial condition that if you plug in 0 for x, you get a -3. Or under the condition that f of 0 is equal to -3. So that tells us that -3 is equal to, well, if we plug in a 0 here and here, that'll be 0 plus 0 plus c, or c equals -3. So our function, which is the particular solution to this differential equation, should be -4x to the 1/2 plus 3x plus c. Okay, so there's our solution. And I'm pretty confident that this is our solution, but let's just double check our solution quickly. So if that's our function, well, what's the derivative of this function? Well, power rule for derivatives, the half comes out front, so that's a -2, drops by 1. Derivative of 3x is, oh, sorry, this, I think I said -3, but I wrote c. -3, sorry about that. So the derivative of the 3x will be a +3, and the derivative of the -3 would be 0. So we take the derivative of our derivative. So again, power rule, the -half comes out front. So -2 times -half is 1. So we get x to the -3/2, and the derivative of 3 would be 0. And we get exactly the second derivative of f that we started with. All right, so that does it for this problem. I hope it was helpful.